Hi everyone, so welcome back to my channel Mathematical Smarty 3226. So in this particular video, I'm going to cover class 11th topic, that is sets, and this is exercise 1.1. So in this particular video, I'm going to cover completely 1.1 with like full explanation. So yes, I hope you will understand this video and it is also going to be very helpful for you. So all the students who are currently in 11th class and or even if you are in 12th or 10th, you can watch this video. So if you are not in that class, I know there are so many, subscribers who are not in class 11th or 12th or even 10th. So you can share it with the concerned person. Okay. So yes, now let's start with the video. Let's start with the detailed solution of all the questions of exercise 1.1. So which of the following are sets? First, let me make you understand what are sets. Okay. In a very simple word, I can say that sets are nothing but it is a collection of well-defined objects. I will make you understand the concept while taking all the questions one by one. That is, I think, like best right now. That I'll make you understand the concept and then I'll take the questions. So, collection of well-defined objects. That is called nothing but sets. I know it is sounding very simple, but here this word well-defined is playing a very important role because well-defined, what is the meaning of well-defined? That means when you are, saying something, you are very sure about it. That is very certain. That is well-defined. For example, let's do the first question. First question is, we have to say which of the following are sets and we have to justify our answer. So talking about the first one, the collection of all the months of a year beginning with the letter J. Can you answer this question? Yes, we can answer this question. The answer is January. Please write down completely. Okay, I'm just writing it here in short. January, then we have June, then we have July, and that is it. We have 3 months. That is, their letters start with J. So that is why it is a set. Okay, let's go to the next question. Because you can also say that it is the collection of this thing is a well-defined. That is why it is a set. Next is the collection of 10 most talented writers of India. Do you have fixed 10 answers? Do you think that every people in this world are going to consider what you are considering as the 10 most talented writers of India? Absolutely not. It depends. It varies from person to person. That means it is not well defined. Because it is not well defined, it is not a set. Let's go to the third question. A team of 11 best cricket batsmen of the world. Again, how can you say that, like these are the only best cricket batsmen of the world? These are the 11 best cricket batsmen of the world. No, you can't decide that. There are, different criteria to, like on which we decide that, okay, this is best, this is best. For me, maybe it's different answer. For you, maybe it's different answer. For the third person, maybe it's different. So, of course, it is not well defined again. So, that is why it is again not a set. Let's go to the fourth question. A collection of all boys in your class. Okay. Here it is specifically mentioned that we are talking about all the boys. Will it be difficult to say between the girls and boys that, okay, whether this is a boy or not? No, there is no problem in that. We can clearly say who are boys in your class. That is why the collection of all boys in your class is well defined. And because it is well defined, because you have an answer for this, you are sure of your answer, that is why it is a set. And what is the reason? Because it is asking justify your answer. So the only reason you can say is because it is well defined. Okay. Next. And which is not a set, you can say it is not well defined. Next is the collection of all natural numbers less than 100. Do you think the answer for this is going to be different for me and different for you? No. It is going to be same throughout. Okay. Or what are the collection of all the natural numbers less than 100? It is 1 to 99, right? So it is fixed only. It is going to be 1 to 99 always. That is why it is a well-defined object. That is why it is a set. Next is the sixth one, the collection of novels written by the writer Munshi Premchand. Now, this is fixed. You can't just say that, like you will take any novel and then you'll say that he is not the writer. If he is the writer, he is the writer only. That means, again, we can collect all those novels which are written by the writer Munshi Premchand. That is why it is again well defined, and that is why it is a set. Next is question number 7, the collection of all even integers. Okay, here you can just think about what do you think is like can be the answer for this question. The collection of all even integers. If I first ask you what is the meaning of integers, what are the meaning of integers? Integers are simply all the negative numbers and all the positive numbers along with zero on the number line. They are called integers, right? Now let us talk about even integers. So of course, you know what are the answers for even integers, right? So it's 2, 4, 6, 8, -2, -4, -6, -8. These all are even integers. We have a fixed answer for this, right? That is why, again, it is well defined. That is why it is also a set. Next is question number 8, the collection of questions in this chapter. For example, let's take this chapter sets. So the collection of all the questions. It is saying the collection of questions. The questions are fixed, right? The questions are going to be same for me, same for you, same for the other one, right? This is NCERT sets questions. So even if you check this book from, like the north part of the India or the south part of the India or the east part or the west part, it is going to be same only. That is why, again, it is well defined. And because it is well defined, it is again a set only. All right, next is question number 9. That is a collection of most dangerous animals of the world. Again, what is the meaning of most dangerous? Like maybe, for me, tiger is the most dangerous. For someone, tiger is like, they're just very comfortable with tiger. Like, of course, the trained people, right? So for them, tiger is not the most dangerous. Again, here, the collection of most dangerous animals of the world is not well defined. And because it is not well defined, it is not a set. Okay. I hope the first question of the exercise 1.1 is very clear. So you can simply justify your answer by writing that it is a set because it is well defined and it is not a set because it is not well defined. Let's go to the second question. So let me show you the second question. Okay. So before I explain the second question, I'll first tell you like a very little concept or the basic concept about sets. First of all, how do we represent sets? We represent sets using capital letters. Always remember this. We represent sets using capital letters. Another question, how do we write sets? We write down the sets, like whatever entries that we write down in the sets, that we always write inside the curly braces. Okay. Now, whatever entries that we are writing inside the set, they are called the elements of the set. Okay. For example, in the second question, you can see we have let a set A, because of course it is denoted by capital letter A, and we have some elements inside the set, which is 1, 2, 3, 4, 5, 6. Insert the appropriate symbol, this or this. Let me tell you that this is called belongs to, and this is called does not belong to. It's as simple as that. So we simply have to say whether this element is in the set or not, whether this element belongs to the set or does not belong to the set. For example, the first question, 5. Do we have 5 in the set? Yes. So the answer is belongs to. Next, 8. Do we have 8 in the set? No, we do not have 8. So does not belong to. 0. Do we have 0? No. So does not belong to. Next, 4. Do we have 4? Yes. So belongs to. Do we have 2? Yes. So belongs to. Do we have 10? No. So does not belong to. I hope this is also very clear that how do we denote sets, like how do we represent sets, how do we write down the elements of the set, of course inside the curly braces, and how do we write down whether the element is in the set or not in the set. So for that, we use this epsilon sign. We also call it as epsilon. But right now, you just have to say it is simply belongs to or does not belong to. It's as simple as that. And I hope you understood this question as well. Now let's move to the next question, and that is the third question. So for the third question, what I'm going to do, I'm just going to put the question once again, and I'll start with the third question. So I'll just make it little smaller so that I can write down the answers here. Okay. Just solve it here. Oh, okay. So, yes, so this is our third question. Okay, perfect. This is the third question. This is looking so elongated now. So let me make it little. Yes. Okay. So we need to write down the following sets in the roster form. Okay, let me tell you, we represent sets or we write down sets in two forms. First is roster form that you can see here, and second is set builder form. So there are two ways to write down the sets: roster form and set builder form. First, let's do the third question, the first one. We have to write down the following set in the roster form. The first set is given: a equals x. How do we read the sentence or statement? Let's understand. A equals x such that, this is a symbol of such that, okay? X such that x is an integer and x is lying between -3 to 7, where -3 is included, okay? So do you know that in the roster form, we simply have to put the values. So for this condition, what do you think can be the values of x? The values of x is going to be, because -3 is included. Why -3 is included? Because it is saying this, okay? Like, and there is equal sign as well. So therefore, -3 is also there. Then we have -2, then we have -1. So these are the possible values of x. And then 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7. So these, okay, no, not 7. Yes. Why not 7? Of course, because 7 is not included. It is simply saying that -3 is in between, sorry, x is in between -3 to 7, where -3 is included, but 7 is not included. All right. So therefore, what is the answer for A? The answer for A is simply -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and we can close the curly bracket. Let's solve the second question. B equals x such that x is a natural number less than 7. This is again very simple. We know the answer for this, right? So in roster form, like personally, I just love solving questions in the roster form because it's so simple. You just need to find out the answer and you need to put the values. So what are the natural numbers less than 6? It's very simple. 1, 2, 3, 4, 5. It is saying less than 6. So 6 we will not include till 5. Why not 0, -1? Of course, you know that natural numbers are those numbers which start from 1. So 0, negative numbers are not possible. Let's go to the third question. So C equals x such that x is a 2-digit natural number such that the sum of its digits is 8. So you have to find all such 2-digit numbers whose sum is going to be 8. Okay. So because it is asking for 2 digits, so of course you have to start from 10 only. So 10 is like, 1 plus 0. Is it 8? No, it is not 8, right? So find out all such pairs where the sum is 8. So the very first is 17. Once you are writing 17, if you want, you can also write down, by reversing this number, which is 71. We have to write down only 2-digit natural numbers, okay? So make sure in sets, the order is not important. You can write down 17 and then 26 and then 44 like that, and then 71 at the end or at the starting. No problem at all. So 17, 71. Next is 26, because the sum is going to be 8. 2 plus 6, 8. Similarly, the reverse one, that is 62. Next, 36. So 63 as well. Next, 44. So if you do the reverse of 44, it is going to be 44 only. So remember one more thing here, the concept that we do not write down the repeated answer or the repeated number in the set. Okay. So make sure you don't repeat it. Next is 53. Right. So if you're writing 53, of course, you have to write down. One second. I did one mistake. Here it is 35. Oh, yes, it is 35. Okay, so the opposite is 53. So 17, 71, 26, 62, 35, 44, 53, and then of course 62 I've written, 71 written, 80. This is very important. 80 sum is also 8 plus 0, 8 only. And after this, we do not have any other possible answers. Therefore, the answer is this only. We can close the bracket. Next is question number 4. D equals x such that x is a prime number which is a divisor of 60. Okay. So very first thing that you need to understand that what is prime number. Prime numbers are those numbers which are divisible by 1 and itself only. Okay, those are prime numbers. So here we need to find out x such that x is a prime number which is a divisor of 60. So let's find out the divisor of 60. How can you find out? Find out the LCM. So it's 2 times 3, 30, 2 times 15, and then 3 times 5. So what are the divisors? And these are also prime numbers. So it's 2, 2, 3, 5. But remember, we do not repeat the element, right? So therefore, we can simply write down 2, 3, 5. That's the answer. Let's go to the question number 5. E equals, we have to write down the sets of all the letters in the word trigonometry. So let's start. It's very simple. T, R, I, of course. Okay, I forgot to tell you, we always write down the elements of the set by, like by separating the elements with a comma. Okay, so don't forget to write down comma as well. T, R, I, G, O, N. And you can see that in this we have O again, but we will not write it. Why? Because we have already written O. Next is M. Yes, we can write down M. Next is E. We will write down E. Next is again T, but we will not write down this T because T we have already written. Again R, we will not write down R because R we have written. Then Y, we have not written this, so we will write it. And that's the answer. Next is question number 6. The set of all the letters in the word better. Okay. So, of course, you know that you have to write down just all the letters once. So, let's write down B and then E and then T and then again T we will not write down, again E we will not write down, and R. So, it's just B, E, T, R, right? Okay. So, we are done with the third question as well. Now let's move to the fourth question. So what I'm going to do, I'll solve the fourth question by just going little below. Okay, so here it's just the vice versa. You have to write down the following sets in the set builder form. I'll just make you understand with the help of roster form. Here you can understand, imagine we got the answer for this question, right? We had got the answer that A equals minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. This was the roster form. And this that you can see here, this is given in the set builder form. So now what is going to happen? You will get this question and you need to find out a general statement that will satisfy all the values that is written inside the set. So you have to write it down in this form. And this form is called the set builder form. It is more like a statement form. So you need to write down some statement. Okay. So for example, question number 4, question number 1. It is saying 3, 6, 9, 12. Now, what do you have to do here? You need to think that what can be the answer for this. So I can just simply say that this 3, 6, 9, and 12, I can write down, let us just note this as set A. So here X such that X is the first 4 multiples. x is the first 4 multiples of 3. Remember, when you are writing the answer in the set builder form, only one answer is not possible. Maybe you can write down the same thing in a different way, that x such that x equals 3n, where n is from 1 to 4. That is also what you can write down. You can write down this as well, that x such that x is the first 4 multiples of 3. What are the first 4 multiples of 3? 3, 6, 9, 12. That's the answer. Okay, let's go to the next question now, and that is question number 2. So it is saying 2, 4, 8, 16, 32. See, I can say here that it is like, the first 5 multiples of 2, but I want to change the answer, okay? I want you to notice here something. Can you notice that this is more looking like 2, then 2 square, then 2 cube, then 2 raised to 4, then 2 raised to 5. It is following some pattern. At the same time, I'm not saying that if you will write down that x such that x is the first 5 multiples of 2 will be incorrect. Absolutely not. That is not going to be incorrect. But I'm just giving you the different conditions. All right. So b equals, because I can see here a pattern and it looks like x such that x equals 2 raised to n. Okay. Where I'll give the condition for n, and the condition for n is simply that n is from, of course, here 1 to 5, right? So it is 1, this is n, and 5, because 1 is also included and 5 is also included. So I need to write out this. So what is the answer? B is equal to x such that x equals 2 raised to n, where n is varying from 1 to 4. Okay. If you are writing 1 to 4, like 1 to 5, it also means one thing, right? We know that if we are saying that n is in between 1 to 5, and if you do not mention that what specifically is n, then you know that between two numbers there are infinitely many numbers. So it is still not very clear. If you just write down something more here, that means this small n belongs to the capital N. Capital N here simply tells you that it is a set of natural numbers. If you're talking about natural numbers, then for this particular thing that I have written here, the answer is going to be just 1, 2, 3, 4, and 5, nothing else. So it's very important to add the condition for n here, and that is n belongs to capital N. And that's the answer. Now let's go to the third question, and that is again, it is looking like something 5 raised to 1, 5 raised to 2, 5 raised to 3, and 5 raised to 4. Again, it's very simple. So you can write down, let C represents the set. So C equals x such that x equals 5 raised to n, where n is varying from, of course, 1 to 4. And then again, the small n belongs to the capital N, just to tell that it is a set of natural numbers only. Okay, next is we have 2, 4, 6, dot, 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 dot. What is the meaning of this dot, dot, dot? It simply tells you that it does not stop anywhere. It just goes on and on. But I can see that 2, 4, 6, these are all even numbers, right? So I can simply say that the fourth question is simply B equals set of all even positive, you can also say even positive integers. That is it. You don't have to add anything else. This is enough information. So the answer is B equals set of all even integers. Okay. All right. So positive integers. Okay. All right. So now the next is, the question is 1, 4, 9 till 100. Okay. So here also you can observe one pattern. Let me write down question number 5. You can see 1, 4, 9, 100. So if I just write down 1 as 1 square, next element is 4, 4 as 2 square, next element is 9, 9 as 3 square, and then it says dot, dot, dot. It simply means the next is 16 only, and that is 4 square. Next is 25 only, that is 5 square. So simply we can write down that the generalized form for this is going to be simply x such that x equals, can you see that we are having only square, square, square only? What is getting changed? This number is getting changed, right? So let us consider that as n this time, and because that power 2 is fixed, so you can just write on n square. Okay, so x such that x equals n square, where of course n, the small n, belongs to natural numbers only, and there is a condition for this n, and that is simply that n is going to be 1 and then lesser than or equal to 10. Why? Because if I put n 10, right? So what is 10 square? It's 100. And 100 is the last number in our set, right? Because it is simply telling you, you can see in the question, that it is 1, 4, 9, the last number is 100. So it can be 10 square, right? That is why this is the answer. All right, so we are done with the fourth question as well. Now let's move to the fifth question. We have only 6 questions here. So let us quickly finish the fifth and sixth question as well. And I'll make the second video, like the second exercise solution, super soon in my next video. Okay. Now let us quickly solve the question number 5 and question number 6. All right, I'll go. Yeah, I wanted to show you the question first. So, in the first question, question number 5, it simply says list all the elements of the following set. Okay, the first one, A equals x such that x is an odd natural number. What is an odd number? Odd numbers are all the numbers which ends with 1, 3, 5, 7, 9, right? So you can write down 1. Of course, we need to follow natural number as well. So it is going to start with 1 only. So 1, 3, 5, 7, 9, right, 11. And do you think that there will be any stop? No. So you can simply write down dot, 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 and then close the curly bracket. This is the answer. Okay, so the next question we have is v equals x such that x is an integer, right? And x has a condition that is in between -half to 9/2. So for the second question, what I'm going to do is, you know that 1/2 is 0.5, right, in decimal form. You know that 9/2 is 4.5 in the decimal form, right? And it is saying that x is in between, okay, sorry, it's -half. So x is in between -half to 9/2. But what is -half? It is -0.5, right? And this is 4.5. So -0.5 and 4.5, you need to list all the integers, right? So this is -0.5, right? So that means x is greater than this. So the very first integer is going to be 0. Of course, there will be no decimal answer because it is saying integers. Integers are the complete numbers, the whole numbers. Okay. 0, then 1, then 2, then 3, and then 4 also, because it is lesser than 4.5. So it is 0, 1, 2, 3, 4. All right, let's do the third question. So the third one, c is equal to x such that x is an integer where x square is less than equal to 4. Okay, this is little interesting here. First, you need to figure out what are the possible values of x. So you can see here that if I put x equals -1, right? So what is -1 square? It's 1 only. 1 is less than equal to 4. Yes, this is correct. Even if I put 1, it is going to be lesser than 4 only. So that is also correct. So -1 is correct. 1 is correct. If I put here negative, let's say 2. So -2 square is going to be negative +4. That means this is 4. Is it satisfying? Yes, it is satisfying because there is an equal sign. So -2 is also correct. Next is, let's put 2. So 2 square is also 4. That means this is also satisfying. Other than these, if I put any number, okay, 0 also, because 0 square is going to be 0 only, and 0 is less than equal to 4. So 0 will also satisfy. But in 0, we do not have any plus minus because 0 is a neutral number. So just 1 0. Even after this, if you just check any other number that will satisfy this condition, there is no such number. For example, if I take negative 3, what is negative 3 square? It's 9. Is 9 less than or equal to 4? No, that is not correct. So therefore, the only possible answers are 0, negative 1, positive 1, negative 2, positive 2. So the answer is 0, comma, plus 1, minus 1, plus 2, minus 2. This is the answer for C. Okay, now let's move to the fourth question. So what I'm going to do is, I'm going to show this question once again, and I'm going to simplify this below. Okay, so let's do question number 4 now. So I'm just writing it here, question number 4. D equals X such that X is a letter in the word loyal, right? Very simple again. So D is simply going to be L, comma O, comma Y, comma A. It is, like sounding like lawyer. Why not that L at the end? Because we can't repeat the elements. That is why just L, comma O, comma Y, comma A. What is the important thing here? To write down these elements inside the curly bracket, to write down these elements by separating with this commas, and yes, and writing the set with a capital letter. That is it. Next is X such that X is a month of year not having 31 days. Okay, so we need to just simply write down all those months in which there are no 31 days. Okay, so January 31 days we cannot write. February, okay, I'm writing in short form. You do not write down in the short form. So February, March 31, April because it has 30. Then May can't write 31. Then June 30. That is also my birthday month. Okay. Anyhow, anyway, so June, and then July 31st, August also 31st, September 30, October 31, November 30, and December 31. So we have all the months whose, like who is not having 31 days are February, April, June, September, and November. Is it? Okay, let's go to the sixth question and the last question of question number 5. And that is X such that F equals X such that X is a consonant. What are consonants? All the letters which are not vowels. What are vowels now? A, E, I, O, U. We have only 5 vowels in the English alphabet. So except these vowels, all the other are just called consonants. But we need to write down here with one more condition that X is a consonant in the English alphabet with which precedes K. That means whatever letters, like whatever alphabets that are consonant, but that comes before K. Precedes is that comes before K. So it's simply A you can't write down because that is not a consonant. So B, C, D. E you cannot write down because that is a vowel, not a consonant. So F, G, H. Okay, so A, B, C, D, E, F, G, H, I you cannot write down, G. And which precedes K, so of course K you will not include. So the answer is B, comma, C, comma, D, comma, F, comma, G, comma, H, comma, J. That is the answer. And we are done with the 5th question. Now let's move to the 6th question. Okay, so in the 6th question, we need to match each of the set on the left in the roster form with the same set on the right described in the set builder form. This is very interesting. So the very first thing that I'll match is question number 3. So question number 3 is with, okay, let's just do the, the lower class thing. That is 3 to D. Don't do it in the exam. Just write on 3 here, okay? Right now, just for the fun, I'm doing this. Next is 1, 2, 3, 6. What can you observe here? X such that X is a prime number and a divisor of 6. It is saying that X is a prime number, right? 6 is not a prime number. So that is why 1 is not the answer. It is also a divisor of 6. So the only answer I can see is 2, 3 because also 2, 3 is a prime number. So this is your second number. Mathematics is done only. Next is 1, 3, 5, 7, 9. This is very simple. Of course, this is all odd natural numbers lesser than 10 because 1, 3, 5, 7, 9. So this is going to be this. That means fourth one is here. Next is x is that x is a natural number and a divisor of 6. Now this is possible because here it is not saying that it should be a prime number. So it is just C. So therefore, this is 1. Okay. Remember, prime numbers are those numbers which are divisible by 1 and itself only. 6 here is not a prime number because 6 is divisible by 1, 6 is divisible by 2, by 3, by 6. It has more than 2 factors. It cannot be a prime number. That is why this is the answer. And that is the end of our video as well. I just wanted to inform you that in the next video, I'm going to cover exercise 1.2, where I'm going to also explain the types of sets. You know, we have a lots of types of sets. So all of those things I'm going to cover in my next video, which I'm going to upload by tomorrow only. So yes, thank you so much for watching this video, and I hope you understood each and every question. Let me know your, views on this video, and not on this video, but in general also, because I really want to know your feedback as well. So yes, thank you so much. And again, I'll just say that if you have not subscribed to my channel yet, please do subscribe to my channel and share these videos with the concerned students or the person. Thank you so much. Have a nice day.